In this video lecture, we will go through some commercial cells and batteries that we commonly use in our day-to-day life, like the cells that we use in calculators, the cells that we use in watches, in hearing aids, right? And we'll also talk about batteries that we commonly use in inverters, in automobiles, in cars, right? And since now we are at the completion of chapter electrochemistry, so this is an application, right? This lecture will tell you the application of electrochemical cells, right? The one that we have studied already. We have gone through Daniel cell, right? How the galvanic cell works, right? So there we said that a redox reaction is taking place, due to which it works. A redox spontaneous reaction takes place, due to which this galvanic cell works, right? And this reaction, this spontaneous redox reaction, is getting utilized in these cells and batteries, right? That is why they work on their own, right, and produce electricity, right? Because we know that in cars we have a big battery there, right, which has, that battery has a combination of electrochemical cells, right? And in those in that battery that consists of electrochemical cells, the redox spontaneous reaction is taking place, due to which that battery works and your lights work in your car, right? It's nothing but electricity, due to which it's lighting up, right, the lights in the car. So, and also the cells that we use in hearing aids, in watches, right, in calculators, transistors, all this are working because you have a cell in it, and that cell can provide electrical energy, right? Because that cell is undergoing a spontaneous redox reaction, right? So now let's talk about some of the cells. The first one is firstly, there are two types of galvanic cells, right? Galvanic cells, two types. The first is primary cells. The second is secondary cells. These are secondary cells. Batteries come under secondary cells, right? And this dry cell and your mercury cell comes under primary cell, right? And we know that what is a battery? Battery is nothing but a combination of electrochemical cells. When electrochemical cells are connected so that they can work together, all cells can work together to produce electrical energy. That's your battery, right? When you need more output, right? When one cell cannot give that much output, so you combine a number of cells, right? So electrochemical cells combine to form batteries, to form a battery, right? So these electrochemical cells work together to produce electrical energy in battery. Now let's introduce to this first cell, which is your dry cell, right? We also call it as a form of Leclanche cell, right? This is a form of Leclanche cell. Now since all these are, this is cell, this is cell, this is battery. So what we would be more concentrating on is, a cell, I said, works because of an electrochemical reaction, or we say it works due to the reaction that takes place at anode and cathode, and we have an electrolyte, right? So we will be looking or concentrating more at these reactions, right? Just try to understand how these reactions are working. And in case of batteries, we know that batteries get discharged and they can be recharged, right? So in these batteries, we will understand the chemical reactions that take place while battery is working, and the chemical reactions that take place when you recharge the battery, right? And just take notice of it, that what products are getting formed during the during the working of battery, that will make it to get discharged, right? So this is the common form of, or a compact form of Leclanche cell, right? It consists of this zinc container. This is zinc container, right? And this zinc container will act as anode, right? And it has a, at the center it has this graphite rod. This graphite rod will act as cathode, right? And this graphite rod is surrounded by this manganese dioxide and carbon, right? And inside the cell we have paste of ammonium chloride and zinc chloride, which acts as electrolyte, right? It acts as electrolyte. This we know this is a cell. Since it's a cell, so it has a metal cap at the top, right? This is the metal cap with which it is closed, positive pole and negative pole, right? So all the conditions of galvanic cell is completed here. You have anode, you have cathode, you have electrolyte, right? Now let's see what reactions take place at anode and cathode, right? And how electrolyte will get used up in the reaction, right? So we call it a dry cell, right? And paste of ammonium chloride and zinc chloride acts as an electrolyte. And this cell will stop working after some time, right? Now let's see why it will stop working after some time, right? Let's first concentrate at the reaction, at the reactions, and this is commonly used in clocks and transistors, right? So at anode, we know that anode is of zinc. So we know that at anode oxidation takes place. So zinc will lose 2 electrons to form zinc ions, right? Now these 2 electrons lost, right, will go to cathode, right? These lost electrons would be gained at cathode, because at cathode your reduction reaction takes place, and at cathode we have is manganese dioxide. This cathode is surrounded by manganese dioxide, right? And this cathode is of graphite rod. So at cathode we have manganese dioxide, right? And we have ammonium, right, from this ammonium chloride, because we know that ammonium chloride will form ammonium ions plus chloride ions, right? So we have at cathode you have all positive ions, so ammonium ion is here, right, plus 2 electrons lost from anode will be gained at cathode, right? So manganese dioxide comes from here, ammonium comes from the electrolyte, and 2 electrons come from the electrons that are lost by zinc, right? Zinc is acting as your cathode. So here it forms Mn2O3, the product would be Mn2O3, right, plus ammonia will get formed, right, plus you have water. This is the reaction that takes place, right? You have 2 ammonia, right? So here Mn, you see that manganese is reduced from +4 to +3, right? We will write manganese is reduced from +4 to +3, right? So here reduction reaction is taking place, and here you notice that ammonia gas is formed. Now this ammonia gas that formed, it will not liberate, it would not be liberated, right, at any electrode or out of cell. This ammonia gas will immediately react with zinc, right, to form a complex compound, right? Let's see what that complex compound is, right? Zinc, ammonia gas, ammonia will react with zinc to form complex salt, which is this. We call it as zinc diamino dichlorozinc, right? Or we call it as dichlorozinc. This complex will get formed, due to which ammonia gas would not be liberated, and due to the reaction between a zinc and this ammonia, it will form this complex salt, complex compound, right? So no long life for this reaction, no long life. You might have noticed that some cells, when they are even kept, are not getting used, they will show leakage. The cells get leaked, right? So what is the reason behind the leakage? Since we said the electrolyte in this cell consists of ammonium chloride, right? And ammonium chloride is acidic in nature. So due to its acidic nature, it will corrode the zinc container, right, in which everything is contained, right? So it will corrode, or it will corrode the zinc container. That is why cell will get, it doesn't have a long life. It keeps getting corroded from inside, right? So cell will, these types of cells will die after some time, right? Because of acidic ammonium chloride, which will corrode your zinc container. No long life because of acidic ammonium chloride, which will corrode zinc container, right? So this is important. Just notice that this is your zinc container, act as a node, and this is your cathode at the center, right? And cathode is surrounded by manganese dioxide and carbon. You have a electrolyte, which is a paste of ammonium chloride and zinc chloride. This is the reaction at cathode, this is the reaction at anode. Ammonia gas will form. This ammonia gas will immediately combine with zinc to form this complex salt, right? And this doesn't have a long life because of acidic nature of ammonium chloride, which will corrode your zinc container, right? So this is it. And these kind of cells are commonly used in clocks and transistors. Now let's look at another cell, which is your mercury cell. Mercury cell, this cell is used in low current devices where low current is needed, right? You have in hearing aids, in clocks, right? So this is used in low current devices, right? And this is your zinc container. It's mostly these cells are the small circular cell that you put in the watches, right, in hand watches. And the hearing aids also, you might have seen the cells in hearing aids, the small circular cells. These are those cells, right? So it consists of the zinc container. You have carbon cathode, right, and you have this electrolyte, which is a paste of mercuric oxide and your KOH, right? So now let's see the reactions that take place at anode and cathode. At anode you have zinc, right? So zinc, and in your electrolyte you have hydroxyl ions. So zinc will combine with hydroxyl ions to form zinc oxide, water, and 2 electrons. Zinc will combine with OH ions, right, to form zinc oxide plus water plus 2 electrons, which will be lost from this zinc metal, right? Then let's see at cathode. At cathode you have, cathode is of carbon, right? And these electrons would migrate to cathode, right, and will combine with water and mercuric oxide. Mercuric oxide plus water plus 2 electrons, it will form mercury plus your 2 OH ions. 2 OH ions will be released. This is the reaction that will take place at cathode, right, in mercury cell, and this is also known as Rubin-Mallory cell. We also call this mercury cell as your Rubin-Mallory cell, right. So the overall reaction would be zinc plus mercuric oxide, zinc plus mercuric oxide, it will form zinc oxide plus mercury, right. Since now just notice that in this reaction the ions are not getting utilized, or ions at the final reaction, ions are not, the concentration of ions is not decreasing, right. We know that in cells, when electrolyte is completely used up, cell reaction will stop. So in this case it's a long life cell because the concentration of ions is not getting changed, right. So it's a long life cell since concentration of ions remains constant, right, almost. But we know that when we keep using these cells, at one time they get discharged, right, because of mercury, right. So these cells should be reprocessed for mercury, right, because mercury is getting used up, right. So these cells needs to be reprocessed for mercury, right. Now let's come to our batteries now, right. We know that battery is nothing but a combination of electrochemical cell, right. And one more thing, since you see that in this reaction mercury is getting released, right. So this mercury, we know that mercury is not good for environment, so this mercury should be prevented from getting released in the environment, right. Now let's see this. This is a electrochemical cell, this is a battery, right, which consists of number of cells. You see 6 cells, right. So it's a combination of 6 cells, right. Now again let's talk about in terms of anode and cathode. Anode you have is lead, right, and cathode is your, this is your cathode, lead dioxide, PbO2, right. Now we know that batteries, you can use battery for quite a long time, and at one point after say 1 year or maybe more than that, the battery gets discharged, right, and then you can again recharge it, right. So let's see this in detail, the charging and recharge, the discharging and recharging of battery, right. So when we say that battery is getting used up, when battery is getting used up, it's discharging, right. So battery when used up, when getting used, is discharging, right. So now let's look at the chemical reaction due to which this battery gets discharged. Since the electrolyte here is your dilute sulfuric acid, right, which will form, we know that ionization, it will form 2 hydrogen ions and sulfate ions, right. And we have anode. Let's see what reaction takes place at anode. Anode consists of these lead rods, right. So at anode, at anode, right, we have sulfate ions in the electrolyte, right. So lead will combine with sulfate ions to form lead sulfate, lead sulfate, right? You might be, you possibly you know about lead sulfate, that lead sulfate is a precipitate, right? So a precipitate of lead sulfate gets formed at anode plus 2 electrons, right? These electrons are coming from this lead, right? So we say PPT, precipitate of lead sulfate, gets formed at anode, right? Now this is lead sulfate and it gets formed at anode, right? So we know that lead sulfate, it sticks to the cathode in this reaction, right? Formed at anode and sticks to it. Now let's see what happens at cathode. This sulfate ions from this electrolyte combines with lead ions. Now these hydrogen ions, right, these hydrogen ions and sulfate ions will combine with PbO2, right, to form lead sulfate and water. PbO2 plus these hydrogen ions plus sulfate ions, right? Since electrons lost at anode would be gained at cathode, so plus 2 electrons. Right, now let's see the product. It will form lead sulfate and water, 2 molecules of water. So you have your 4 hydrogen ions, let's try to balance it, and 2 electrons. It will form PbSO4 plus your water, 2 molecules of water. So we see that even at cathode, a precipitate of lead sulfate gets formed, right? So these are the reactions that are taking place when battery is getting used, right? When you are using battery, these reactions are taking place, right? At cathode. So at anode and cathode, lead sulfate gets formed and sticks to these electrodes, right? So due to the deposition of lead sulfate, right, this reaction will stop at one point. And since we said that this sulfuric acid ionizes to form sulfate ions, and these sulfate ions are getting utilized in these reactions, right? So concentration of sulfuric acid will decrease, right? So when sulfuric acid will completely get used up, this reaction will stop, right? Since sulfate ions are utilized, right, so concentration of sulfuric acid will decrease, right? So during the time the battery gets used up, lead sulfate will get formed at cathode and anode, right? It will stick to anode and cathode, right? Due to which the reaction between lead and lead oxide, the reaction of lead and lead oxide would be prevented, right? Because now we have deposition of lead sulfate, right? So this sulfate ions would not be able to come in contact with lead and lead oxide, and hydrogen ions also would not be able to come in contact with lead oxide due to the deposition of lead sulfate, right? And also, since sulfate ions are getting used up in the reaction, the concentration of sulfuric acid will decrease, right? So once sulfuric acid is totally consumed, your battery will go down, right? Battery will stop. Now here in this reaction, this battery is acting as electrochemical cell. It's acting as electrochemical cell, since due to these reactions it's producing electric current, and due to this electric current or these reactions, the batteries in the cars, right, and the batteries in the inverters are working and they are producing electricity, right. Now we know that batteries can be recharged, right. So let's see what happens at recharge. During recharge, what you do is you take a source of direct current like generator, and you connect the generator to this battery, or you connect the battery to the generator. Now let's see. So what if you just think, right, on this reaction, what recharging will do, it will remove this lead sulfate from anode and cathode, right, and will regenerate sulfuric acid. That is, it will restore battery to what it was when it was new, right. So during charging, or we say recharging, let's see what will happen at recharging. Lead sulfate, right, lead sulfate at cathode will combine with 2 electrons to form lead ions, to form lead plus sulfate ions, right. This reaction will take place at cathode, and at anode, this is at cathode, right, and at anode, PbSO4 will react with water to form PbO2, because we know that at cathode we have a deposition of lead oxide at cathode, right. So PbO2 plus sulfate ions this is the reaction that takes place at anode. So you have lead dioxide or lead oxide is recovered, right, due to this reaction, right. You have lead dioxide, this is at cathode, right, and you have this which is at anode, which is what we want, right, because initially when battery started working, it had the anode is of lead and cathode is of PbO2, right, and you have sulfate ions that gets formed and hydrogen ions, right. So here sulfuric acid is recovered in this reaction, right, it forms sulfuric acid. From these you have sulfate ions are also getting formed here, and hydrogen ions are also getting formed due to this reaction. So sulfuric acid, which is an electrolyte, is recovered, right. Sulfuric acid is recovered in this reaction. So the battery went back to the stage when it was new, right, and again it will start working. This is how, and these are the reactions that takes place at recharging of battery, right. So this is how battery gets discharged due to the reaction, due to these reactions which produces lead sulfate, right. So when you combine it to an direct current source, which is a generator, it will reverse the flow of electrons, right. So charging, let's say recharging will reverse the flow of electrons, right. And this is your lead storage battery. We call it a lead storage battery that consists of 6 cells, right, and each cell is of 2 volt. So this battery is a 12 volt battery, right. Each cell is of 2 volt, right. So 6 cells, it's a 12 volt battery, right. Now similar to this, there is also one battery that is there in your books. It's called as nickel cadmium battery, like nickel cadmium battery. This battery is getting more utilized these days. In this anode consists of nickel metal, right, and cathode is metal grid containing nickel oxide. Anode is your cadmium and cathode is your nickel oxide, metal oxide, NiO2.